This green mass, which is again extracted with water, later that extracted, which is treated with acid solution to get a potassium paramanganate, MnO4 treated with water to form what? MnO2 with the formation of what? 4OH minus ion. Sulfurous acid can easily undergo oxidation by using what? Paramanganate as an oxidizing agent. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidyashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called D and F block element. Under that, we have deeply discussed with the preparation of potassium dichromate. In that, we have discussed about the method of preparation of potassium dichromate in a 3-step, and also we have discussed about the physical and chemical properties of potassium dichromate. At the last, we also discussed about the uses of potassium dichromate. Today, let us move on to the next topic of this unit by understanding the potassium paramanganate preparation. So, how we can easily prepare the potassium paramanganate, that we are going to understand in this session. Along with us, we are going to discuss with the physical and chemical properties of potassium paramanganate. Let's see how we can easily prepare the potassium paramanganate. Already I have discussed that both potassium dichromate as well as potassium paramanganate, these two are important chemicals which we are using in the chemistry. Is it right? Yes, we need to know that preparation. Okay. So, potassium paramanganate is prepared by fusion of MnO2, that is manganese dioxide, with KOH in presence of oxidizing agent known as KNO3. The mass of green with formation of potassium manganate will be formed. So, how does potassium manganate will be obtained? By considering manganese dioxide, which is allowed to react with KOH, which is a base, in presence of oxygen with a very strong oxidizing agent known as KNO3. What does it forms? It forms K2MnO4. This K2MnO4, which is nothing but a potassium manganate, which is known as what? Potassium manganate, with the formation of water molecule, and this will be in the green color. The fused mass is extracted with water and the solution is now treated with acidic solution of K2MnO4. This proportionation reactions will be taking place to give potassium paramanganate. To give what? Potassium paramanganate. Here you can see that after doing the extraction of this green mass with water, we are taking potassium manganese or potassium manganate, which is allowed to react with acid. Okay, here I have considered what? H2SO4, because we are treating with acidic solution. What does it happen? It forms what? Potassium paramanganate with the formation of manganese dioxide and potassium sulfate along with the formation of water. You can see that this reaction can also be written in a two-way, that is manganese MnO4 2- reacting with the acidic solution to form what? MnO4- with the formation of MnO2 and water. So, either you can write this molecular reaction, either you can write this reaction in a ionic form also. So, both the reactions are one and the same. This is how we are preparing the potassium paramanganate by using what? Manganese dioxide. By using manganese dioxide, you are preparing what? Potassium paramanganate, and it is very simple processes. We'll recall it once again. Okay, we are taking what? Manganese dioxide, which is allowed to react with very strong bases along with the oxygen in presence of very good oxidizing agent, that is KNO3. It forms what? It forms a potassium manganate. It forms what? Potassium manganate, which is a green in color. This green mass, which is again extracted with water, later that extracted, which is treated with acid solution to get a potassium paramanganate with the formation of manganese dioxide along with potassium sulfate with the water molecule. This indicates that we can easily prepare the potassium paramanganate by using what? Manganese dioxide. And this potassium paramanganate can also be prepared in a two-way, either by commercial, either by industrially. So first I'll go with the commercial preparation of this potassium paramanganate. Commercially, it is prepared by alkaline oxidative fusion of MnO2 followed by electrolytic oxidation of manganese 6. You can see that they have considered the manganese dioxide, which is again fused with KOH in presence of oxygen, or by considering KNO3, which is a very good oxidizing agent. So it forms what? Manganate ion. So which is nothing but a green in color. So this green extract again treated with the water followed by electrolytic oxidation in alkaline medium to form what? Purple color potassium paramanganate. To form what? Potassium paramanganate. This is a one way where you can easily prepare the potassium paramanganate commercially. We have one more method in industrially. Okay, the Mn2 plus salt can be oxidized by peroxodisulfide ion to form paramanganate ion. You can see that in acidic medium, this MnO4 minus, which is nothing but a green in mass, so which is a green color extract we are obtaining after treating with the water, which has been treated with an acid. It forms what? Mn2 plus with the formation of 4 water molecule. So the neutral or in a faintly basic medium, you can see that how does that reactions will be goes. You can see that MnO4 treated with water to form what? MnO2 with the formation of what? 4OH minus ion. This indicates that laboratory also we can easily prepare Mn2 plus salt by oxidizing with peroxodisulfide ion to the paramanganate ion. Okay. Next we have physical properties of this potassium paramanganate. So we all know that this potassium paramanganate, which is a dark purple color solid, is it right? And it is crystalline in nature. So it is a dark purple color crystalline solid which forms a dark purple in rhombic prism, and it is isomorphous with potassium perchloride. Here you can see that I have used the word isomorphous. What does it mean? Both the structure of potassium paramanganate and potassium perchloride, which have a similar structure, such structures are known as what? Isomorphous, and a phenomena which is known as what? Isomorphism. Okay, and it is fairly soluble in water, about 6.4 gram per 100 grams of water at 20 degrees Celsius. This is how you will understand the physical properties of potassium paramanganate. Whereas in your second PUC, you will do this titration by using potassium paramanganate. So in that, you will see that how that purple color solutions will be obtained by potassium paramanganate. Okay. You can see that the structure here, the structure of manganite and paramanganate ion. You can see that both will have a tetrahedral structure and which consists of manganese surrounded by 4 oxygen atom, and we write the structure as MnO4 2-. So it is Mn. You can see that between the 2 oxygen atom we have a double bond and we have 2 oxygen atom which carries what? Negative charges. Is it right? So it is a tetrahedral manganite which is green in color. Similarly, we have one more structure that is known as paramanganate, and it is also exists in tetrahedral structure, but it is purple in color only because we write a structure of MnO4 minus. So why does MnO4 minus? Because it accepts one of the electron, hence it get the negative charge. Hence one of the oxygen is having negative charge, their color as well as their formula will be different. Okay. So hope you all understood with this structure of paramanganate as well as with the manganate. Next we have the chemical properties of this potassium paramanganate. So I'll go with the reactions of the heat. As we have studied in case of potassium dichromate, similar kind of reactions will be also followed here. So you need to understand that how does it react with the heat, how does it act like a very good oxidizing agent, we'll understand one by one. Action of heat. So potassium paramanganate upon heating undergo decomposition with the evolution of what? Oxygen gas. You can see that potassium paramanganate upon heating which undergo decomposition to evolve what? Oxygen gas, to evolve the oxygen. And also this potassium paramanganate which is acting like a very good oxidizing agent. Let's see with the reaction now. Potassium paramanganate is powerful oxidizing agent. It acts as a oxidizing agent in alkaline, neutral as well as in the acidic medium. We'll see with the example so that you will understand. First I'll go with the acid solution. In that, how does this potassium paramanganate will act like a very good oxidizing agent? We'll understand now. You can see that MnO4 8H plus, which is nothing but an acid, which gives rise to what? Mn2 plus. So which gives rise to what? Mn2 plus. This indicates that our potassium permanganate is a very good oxidizing agent in the acidic solution. Okay. Next we have the following reaction. MnO4 minus oxidizes the iodide to the iodine. You can see here when potassium permanganate reacting with acid, it gets converted into Mn2 plus with the formation of water molecule. As I said that it oxidizes the iodide to the iodine. You can see that iodide which is having the negative charge which get converted into positive charge by losing its electron. Is it right? So it is I2. So for my simple calculation, I will multiply this whole reaction with the 2 and a whole reaction with the 5. And the final equation you will get it as 10I plus 2MnO4 plus 16H plus give rise to 2Mn2 plus 8 water molecules and 5I2. Here you can see that 5 electron and 5 electrons will be get cancelled out. Okay. Next we have one more reactions. Okay. Where does the potassium permanganate can easily react with the acid. So it oxidizes the iron from +2 oxidation state to the +3 oxidation state. If the iron is getting changes from +2 to +3, you can see that color is also get changes from green to yellow. So MnO4 minus reacting with an acid, it forms what? Mn2 plus with the formation of water molecule. As I have said that it oxidizes the Fe2 plus to the Fe3 plus by losing one electron, you know. So I will multiply with the enter reaction with the 5. So I will write 5 Fe2 plus MnO4 with 8 H plus ion. Again this 5 electron and 5 electrons will be get cancelled out. Mn2 plus and with the 4 water molecule and 5 Fe3 plus. This indicates that the iron from +2 oxidation state is get converted into +3 oxidation state, and the color is also changes from green to yellow. We have one more reactions, that is it oxidizes the oxalate ion or oxalic acid into carbon dioxide at 333 Kelvin. So MnO4 reacting with acid, as we know that it releases what? Mn2 plus with the formation of 4 water molecule. As I said that it oxidizes the oxalate ion. I have considered the oxalate ion which decomposes to give carbon dioxide with the liberation of 2 electron. I will multiply the entire first equation with the 2 and second equation with the 5. So that the reactions will be written like this: 5 C2O4 2 minus and 2 MnO4 16 H plus. Again 5 electrons and 5 electrons will be get cancelled out, and 2 Mn2 plus and 8 water molecules and 10 carbon dioxide. This indicates that our potassium permanganate can oxalate ions into the carbon dioxide. So we have one more example, that is hydrogen sulfide is oxidizes to sulfur in the form of precipitate. You can see that MnO4 reacting with the acid to form Mn2 plus and 4 water molecule. As I have said that it oxidizes the hydrogen sulfide, it gives rise to what? Sulfur, which is a precipitate. You can see that reaction 5s 2 minus plus 2 MnO4 16 H plus. Again 5 electrons and 5 electrons will be get cancelled out. 2 Mn2 plus and 8 water molecule and 5 S. This indicates that in an acidic medium, our potassium permanganate can act like a very good oxidizing agent. The sulfurous acid or sulfide, which is get oxidizes to sulfate and sulfuric acid. You can see that when it is reacting with MnO4 minus permanganate with the H plus, what does it happen? Sulfuric acid or sulfate, it get oxidizes to sulfuric acid. It get oxidizes to sulfuric acid. So this indicates that sulfurous acid can easily undergo oxidation by using what? Permanganate as an oxidizing agent. Similarly, the nitrate is get oxidized to nitrate. So MnO4 minus reacting with H plus with NO3 minus, which gives us to what? Mn2 plus with H2O as well as with a nitrate. So from all this reaction, we clearly understood that potassium permanganate, which is acting like a very good oxidizing agent in the acidic, in the basic as well as in the neutral medium. How does it act as like a oxidizing agent? I'll go with permanganate oxidizes iodide to what? Iodine or to iodate. Okay. So you can see that permanganate reacting with water, that is a base. Okay. So what does it forms? It reacting with the iodide to form OH minus ion as well as with the iodate. You can see that OI3 it is, or IO3 minus. Similarly, thiosulfide is oxidizes to sulfur if you use the neutral medium. So you can see that MnO4 minus, that is a permanganate reacting with SO3 2 minus, which is the thiosulfate. When it is reacting with water, it forms manganese dioxide with the formation of what? Sulfate along with the formation of 2OH minus ion. So from these two reactions, it is clearly understood that our potassium permanganate, which also acting like a very good oxidizing agent in neutral or faintly alkaline medium. So we have two more reaction, that is manganese salts, which is oxidizes to MnO2 in presence of zinc sulfate or zinc oxide as a catalyst. Okay, so you can see that manganese salts, which is allowed to react with the water, which get oxidizes to what? MnO4 in presence of what? Zinc sulfate as a catalyst. Zinc sulfate as a catalyst. So let's see with the uses of this potassium permanganate. As I have said that, which is a crystalline solid, which will be also used for bleaching of wool, cotton, silk and other fibers, for decolorization of oil, as well as in the dependent on the strong oxidizing agent. So in order to bleach the cotton, in order to bleach the silk, as well as in the textile industry, it will be used as a bleaching agent. And also, it is also used as decolorizing agent depending upon the nature of the oxidizing power. So by this, I like to say that for all the things which I covered in this session, it is very, very important for the examination point of view, because already I have told that potassium dichromate and potassium permanganate are these two important compounds. You must understand their preparation as well as their physical and chemical property, because for the board, their preparation is important. For the CET and all, it is very important to know their physical and chemical properties. Okay, have a look on it. In the next session, again we are going to continue with the F block element. Till now, whatever I have done, it is only for D block. So in the next session, we'll start with the F block. So what are the F block and how we can see the F block in the periodic table, that we are going to understand. Okay. So thank you. We'll meet you with the next session. Till that, take care. Be safe. Thank you.